Hey, welcome back to the Build It Basement. I'm Kerm, so hopefully you've tuned in to check out some Voron Trident build today. We're going to be working on the AB drives, finally getting the front idlers on. I've been messing with for seemingly forever, and towards the end of the video, we're going to do some linear rail stuff. So hopefully you stick around for the whole video. Hopefully you give me a thumbs up if you enjoy the video, and hopefully if you haven't yet, you go ahead and subscribe. All right, pardon the frame being in the way today, but we're working on the full thing. So today we're going to jump into some ASAs here and see what we get on the printer and see how far we get in general. But we're going to start off with the Ys. And so right here on page 40. Right here, page 41, they're showing us back versus front. This is actually with the printer facing upwards. So there is a time here we're going to be flipping that printer upside down, but it's kind of an overview here. We see our front idlers, we see our A and our B drive units, we see our back here, and our back gantry support, as well as some squaring blocks that are back here as well. So there we go. All right, so first things first, they're giving us a good side view over here on the right-hand side to show us that we're working on the right-hand side. And we're going to start off by putting some roll nuts in. This is the first time we've used roll nuts in this build. Particularly a little bit different on my build versus the build that we see right now on the PDF. And that is the function of the 5 and the 3 roll nuts. Right here I have some 3s and I have some 5s. And depending on your build, depending on what AB drive units, depending on what front idlers and some other things that you have with that going on your printer, you'll be using different roll-in nuts. Now these roll-in nuts are determined by the screws that are going to them. Obviously if you're using an M3 screw, you're going to be using an M3 roll nut. The best way to kind of figure out in advance as to what you're going to need is to look at your drive units and see basically the hole size. Now that right there would be an M5, that right there would be an M5, and that right there would be an M3. So we have M5, 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 M3. So 3 M5, 1 M3 on that one. And here we have 4 M5s and no M3s. Based on direction, and because we're trying to keep stuff here kind of in a similar order as to how it's going on the printer itself, we know for a fact that this is going to be oriented in such a way, and this one's going to be oriented on the other side, or installed I should say. So on this side right here, we know M5, M5, we know M5, M3. So let's start off with doing those. So the best way to put these in, if you are having difficulty, is to place them in like that. Grab yourself a driver of some sort and simply give them a quick little twist over like this. That should align them like that, okay? And then, so we know we have M5, M5. On the back side here, we have M5 closer to the back frame with M3 in the front. And that is what's in the photo. So we're gonna just copy that up. And I'm doing these ones upside down. It's something that I'm relatively used to doing. So when you make videos, you get used to doing something upside down, backwards. Sometimes it's trying. So, all right, now this side right here, as we notice, we're using M5s all the way around over here. So M5s front and back, and then M5s on the bottom, 100%. Like that. And then putting them in, I'm getting these in just my hand, and basically I'm just rolling them in. They're roll nuts, and you can literally roll them in. It's kind of cool like that, right? So orientation, the way they're showing them here is they're putting them in all in one direction, which works quite well. Another way you can put them in is basically small side to small side. Let me show you that real quick. So roll nuts can go in like this. That keeps your holes close. They can go in this, so that keeps them kind of organized in the same direction. Or they can also go in like this, which gives them some spacing but allows you to get closer to the ends. So you want to be aware of that when you roll these in. that sometimes you want them in certain directions. They don't always go in the same way depending on where they need to get close into. So I'm gonna go ahead and check mine out, make sure I got them in the ways I want them. And these ones right here, actually, I'm going to change a little bit. And to pull these out, that can be fun. The best way that I know is to basically put a screw in them. And this might not work on an M5 as well as it does on an M3, but if you put a screw in them, you can kind of leverage them out like that. Now, that's not working with an M5, so I'm going to actually pull it over to the side like this and try to, yep, flick it out like that. So that works out just fine. Flip it around, put it in like this, because I need these relatively close, because I know that those are pretty close together. These two over here are just fine. I'm going to flip this over real quick. See how my other ones are. And I did the same thing over here. I guess with the M3s here, let me show you that real quick. Just pop that like that. I'm just going to flip it around. There we go. Easy mistake to make. Pay attention to it when you're doing it, and you want to flip them around like this, but if you do need to pull them out, that's kind of the best way I know how, is to get something in them and kind of jag them sideways. If you're having trouble getting it out once you do that, you can then flip them around, grab them with something. Just try not to hurt the threads too much, if at all. So we got that. And I actually did both sides on mine. So we've gone ahead and we've done what they show here on this back side for both sides, and I need to do the front side. Now, the one thing I will keep in mind here on the front side is on the original Trident idler, or the idler on the 2.4 and the Trident, uses M5s on both sides. Mine does as well. And these are my modified beefy idlers. I don't have another name other than that for them. So I will leave a link to these down in the description for the video. But these are a modification from Clee, which are a modification from a user of a user of a user. I don't remember all the names, so that's all you're going to get. So I'm going to put in my roll nuts like this. And you can orient these. So these are actually spaced, so the roll nuts can go in back to back, like so. At least that's how I designed it. However, as long as you keep your roll nuts with a good spacing in them, you should be all set. And I'll show you a little trick in a little bit here on how to get your screws started on roll nuts, because you're kind of going blind when you try to connect to those. So I know all of these are going to be M5, so I'm going to go ahead and get these all in. Now, if you've ever seen a Voron 0, which is now a 0.2, it was a 0.1. One of the biggest things about that printer is they actually use actual square nuts to put things together in that, which means that you can't roll them in. So you have to preload all the nuts, and that's kind of one of the most frustrating things about that particular build, is the fact that like all these right here, you would have had to put them in the frame before you actually got to this point, or else you're taking your frame apart in order to put them in. So if you ever decide you want to build a V0, keep that in mind. That does make it more difficult. There we go. All right. Let's see here, 42 and then Y, and now they're showing us here on the other side, which we've already done. These are all M5s this time around. So M5s all the way around this side, which is my left-hand side. On the right-hand side, M5s across the board with the single M3 here, which matches the M3 that we have on this B drive unit. A unit, B unit. B unit has the wire pass-through for it. In this case, we have a CAN connection on it, so it's part of the build we're doing today, but yours might look a little bit different. You might have just another piece here. You might have a different switch here. Actually, let's talk about that while we're on it for a second, because there are options for your end stop switches. One option is basically to have a pod on top of this guy, so that basically you have a switch here, and then you have another end stop switch on your other side here for your X and your Y. There's also these types of units which can house an X and a Y end stop. These are very, very common. This right here has the cutouts here for your X and your Y end stop, and that would mount underneath a drive unit. Or what we're going to be doing with this printer is basically sensorless homing. Now, sensorless homing is kind of interesting, and what it does is it basically, I use the word compute, even though it's not the right word, but basically it computes or you help it compute what the proper amount of current that a stepper motor needs to do normal movements. And then once the unit sees a jump in that current beyond what it knows is normal, it knows it's reached a stop point. It knows it's reached a point where it can't go any further and it's kind of being held up, which is basically its stop point. It's end stop, it's zero position. So because of the fact that the motor's getting stressed out a little bit, it stops it, and that is your end stop, and that's sensorless homing because there's not actually a physical switch. The sensing is actually happening in the software. So anyways, 43, we're doing the left-hand side. We already did that just now, and now back to putting on our front idlers. Front idlers using M5 by 10s. M5 screws, these are the larger screws you're going to be using. On mine, I'm using, again, my modified beefies, and pretty proud of them. I like them. They seem to work pretty good. And here is, let's see if I can get this properly in the frame, the best way that I know to put these together. So what I like to do is get them away from where you need to be. And I hope this kind of shows up on camera. I know it's kind of underneath. Let me see if I can, does that work better? Yeah, I think that works a little bit better. Let me see if that works right there. Yeah, okay. Let me show you what I do. So I can see this right now, and I can see that one. So I'm going to put this one in right here. And I'm not going to tighten this up all the way. I'm just going to loosely put it on. So now it's attached to that roll nut. So wherever I move this, it's going to hold onto that roll nut. So that means I can now use this unit to line up the hole in the second one. I don't have to try to get in there and finagle that roll nut from behind. I can just use my plastic piece. And as long as I just keep these relatively loose, those roll nuts will move around with me. So I'm going to make sure I keep these loose because remember, we do have two more on the underside we're going to put in a moment. But for now, let's get this side together. I'm going to do the same thing once again. I'm going to pull these away and slide this over. I'm going to grab these M5 units. Put that one in. Slide that back until I can line that up. And the other thing you can do is you can put your tool in and kind of wiggle it till you get it where you want it. Now, if you find yourself having a lot of difficulty, you can get your screw in there and you can kind of jog this back and forth a little bit, and you can get it that way as well. But the big thing is get one on there. That'll allow you to kind of move stuff around while it's on there nice. So we got those on that side. I'm going to flip it over now. And I'm going to do similar stuff. Grab these, pull these away. Grab that first one. Just need a couple threads, 2 or 3. See, that one's not lined up yet, so if I move a little bit, there we go. Now it's on. Same thing on this side, pull it away. Line it up. Pull it forward. That one lined up, and then I'm gonna pull those forward. Now I'm gonna pull these all the way forward, depending on your setup, and most of them should be designed in such a way so you can pull them all the way forward to do what you need to do. They're saying slide them into place, loosen the M5 bolts, so that's what we're going to do. I'm going to now finger tighten these, and when I say finger tighten in this particular instance, I mean I'm going to basically tighten them down, but I'm not going to really ream them down. And just a little quick note on when you're screwing plastic together. I mean, you are going metal to metal here, but you have plastic in the middle, so keep that in mind. You know, you can crush that plastic if you really monkey it around and give it too much force. When I do a final tighten of these, I'm going to use a different Allen tool so I can get in there a little bit better. But right there, they're where they need to be. They're nice and tight. That looks good. All right. So slide in place, we've done that. We're now looking at the y-axis. We've done that as well. I always find it easier when you're doing one thing. If you look ahead a little bit, you can follow manual step by step, especially if you're really worried about it. But a lot of things you do in duplicate. So if you do one, you do the other, it happens quick. Now we're gonna do our drive units. Okay, so this time, which is kind of odd, they have you actually starting, and they don't show you here, but I believe, actually I'm quite sure, that we're starting with the A unit, which kind of makes sense. So we're starting over here on this side. And the reason I'm saying that is because I see the double M5s on the top and bottom for this one, which means it's the A and not the B, because the B has the 3mm screw on one of the connections. So we're going to be putting this in like so. This is a little different too, because you actually have to kind of finagle it in a little bit. Now you might have to loosen things up if you can't get it in, but you shouldn't have to take it apart. You get that one in just enough. And we'll get this one in just enough. I'm going to follow my own advice here. I'm going to jump over to this side before I flip everything around here. They show us doing the top and bottom, but I'm going to flip the printer when I do it. And there we go. That one. That should be pretty close. There we go there. Put those two on. All right, I'm gonna flip it around again here now. And I see right here I have my M3 and my M5. I'm gonna start with my M5 because we're doing M5s right now. There's no need to switch up my screws, switch up my tool, everything else, just keep moving with it, you know? There we go. Pretty loose. Move that to the back. And now I am going to do my M3. Now, what I don't recall on, let's see here, page, we did that, yes, the Hall effect. Okay, let's talk a little bit about that. So on the bottom side here, depending on the build you're doing, and depending if you're using Hall effect or not, what you may wind up doing is installing this guy right here. And again, this would be on the right-hand side of the printer if it was facing normal, but for us today, it's over here. And basically, it uses, this is why, or one of the reasons why it's an M5 and an M3, so that basically you have room for that screw, because you don't have all that much room using this. This would be a magnet in here, so when you print this particular piece, it comes with a support piece in here, and what you're going to have to do is get behind it and pop it out with either an X-Acto knife or a very small tool of your choosing. And then you're going to wind up putting a magnet in here at some point. They're actually not showing it coming out at all. And this would also be an accent piece, quite possibly, if you have a kit or if you're printing off your own parts. We're not using a Hall effect because we're doing, again, sensorless homing. So we're going to put that aside. And they're saying an M3 by 12 on this. And I don't really need M3 by 12. I can use an M3 by 10 and have plenty there. So grab an M3 by 10. Sometimes it's good to have spare parts. M3 by 10. Like that. And there we go. Boom. And on the back side of that, make sure these are tightened up a little bit. Recall if we did that. I think we're okay. Okay, so now we have these where we want them. I'm going to just give them a little bit of a light tighten because I don't want these screws to fall out when we flip this back over. So again, very, very light finger tightening on these. Like that. I'm going to flip this back around. There we go. We got our AB drives, front idlers. All right. We are on page 48 and we're zooming. All right. We didn't use an M5 by 16 because, again, we didn't use this Hall effect end stop. So if we had used that, then we would need longer screws, obviously, to get through the plastic. This is why I basically was able to use the 10 size. So now what they want us to do is the rear brace. Okay, so we're going to be working on the de-extrusion, which is this guy right here, and we know it's the proper extrusion because it perfectly fits right between these two guys right here. So we know this is going to fit in between there. So they want us to do a couple of M5 nuts on this, roll nuts, and they're also showing us orientations all facing the same direction. I'm gonna go ahead and follow this to the T because this is the first time I've done this. So this one and this one. And on the other side, we're going to face them the opposite direction. Like that. Then we're going to flip this over, and I'm going to do the same thing again. This is kind of the part, or the good portion of the printer. Once you get the frame done, once you kind of get into a groove, that you really start actually moving around pretty quickly with your print build. It's going to go pretty quick from here until we get to electronics. And once you get to electronics, it becomes a little bit more work because you're going to do computer stuff. And I think one of the biggest problems with building a printer is the fact that there are so many variables when you're doing the electronics. When you're doing your program, when you're doing your MCU, which is your control board, control unit, your microcontroller unit, your Raspberry Pi, the versions of that. What kind of, there's just so many things that could be different between your build and somebody else's. This stuff is all pretty generalized, the same with the exception of some mods that you might do. So we have that. I'm going to call this the top. I'm going to call this the bottom. And we're going to put two more M5s. This time they're going to face away from each other, much like the picture. And that is our de-extrusion. All right, so they want us to slide the de-extrusion in. And when we do that, we're going to slide in so that our additional roll nuts are facing downwards. So it's going to go in like this. Now, this time around, we can't move this around to do what we need to do if we need to set this thing up. So I'm going to just kind of line this up in advance. I'm going to basically be pushing this one out a little bit, pushing this one in. We're going to basically get these right to the edges. This should be pretty close to where they're going to wind up in the end. Maybe not exact, but close enough so that we can actually get to the holes. If we can get to the holes, we can kind of work them out and get them where we need them to be. So this is going to be tricky because we don't have a lot of flexibility here on these parts, and we definitely don't want to break them. So they show us going one side in first. Let's try that. So basically, something like this. Yeah, that's kind of sort of working. Kind of sort of. Not really happy with that. Here's what I'm going to do. We left these relatively loose. Not quite loose enough, but we're going to loosen them up just a little bit more. And we're going to make this a little easier on ourselves. So what I'm going to do is I'm going to actually bring this one away. I'm going to slide it in like that because now I have plenty of room to work with. And then this one I'm going to actually pull away as well. Oh, I'm going to loosen up that M3. Like that. And now that we have these loose, we can kind of finagle them a little bit better. There we go. All right. Slide them back into place like that. And then we're going to get our M5 by 10s on this, and you'll have to pardon me here because I'm gonna flip it around so I can actually see where my screws are, because I would be flying completely blind if I went the other way here. I'm going to try to equal this out distance-wise between front and back. I want this to have kind of an equal distance between the two. You can kind of eyeball that. It's not hugely critical. But we do want to be kind of symmetrical. Symmetry is nice when you're working on things like this. And see right here, I don't have them where I need them exactly, but I'm just going to reach in with my tool, slide them over a little bit. Couple threads in. Drop a screw. Okay. Then we're going to flip this thing over. And let's see how far off we are here. We are pretty far off, so I'm going to reach in, I'm going to put this over. I'm going to then grab this one over and slide it into place. I'm going to do the same thing with this one right here. Let's see, where is this one? This one's too far over, so I'm going to pull that one back a little bit. And then I'm going to push this over. You wind up in a really hard spot. You can also use a nice neodymium magnet to kind of work it around, because it is loose in there until you get a screw into it. It will slide in that channel without much effort. Better than taking the whole thing apart. That's kind of the goal now, is to not move backwards. You want to have a nice solid square frame. You want to basically pay attention to what you're doing and move forward. Now, one thing I will say is I never tighten up fully all my screws on any of the drive portions until I get to the point where we're going to put belts on. And the reason for that is having a little bit of play in things sometimes can help when you need to kind of finagle things in and out. So we're just going to barely finger tighten these. In the end of the day, this is just a back brace. This really isn't overly functional other than to support your drive units on the back here. So there we go. We have our, let's see here, we're doubly backwards here. You know, I'm backwards on camera on top of the fact that this is the back of the printer. So this would be the A and this would be the B. I know that because I just had to take a second to figure it out, but also I got my little wire cover there. So, all right, page 50 is done. Rear brace. Now, this right here, this is kind of an important thing that could definitely, if you're not following directions, you're not reading things as you go through, is that this is an offset piece. It looks kind of funny. I know you're on this side, you're not seeing it all on this side. You probably can't see it because of the camera angle, but hopefully with this camera, this guy right here, you can see this a little bit. This is an offset piece, which means that we need to use these in such a fashion that puts them where it needs to be, because these are also printed offset. So these are going to basically hold that, even though this is offset a little bit. It's probably, honestly, probably a slight design flaw that was fixed with very simple, you know, ingenuity. All being because this back piece right here, it's holding the A and B together, is slightly pushed forward because of the way that the structures are here. So obviously it doesn't line up with this. So these parts came into play. They don't make, as far as I know, an aluminum part for these like they do on some where you can get some 45/90 degree units, which is why these are printed as opposed to like that. So yeah, that's why they go in and they're talking about how they're all offset and whatnot. So we already have our M5s up here. We do not have any in this real quick. We're going to put them in, and these ones right here, it looks like we're putting the holes towards the top. And sometimes if these are difficult, which these ones are holding in place, but sometimes what you kind of need to do, and it's kind of hard to show, is put something in so it can't fall. Obviously you can always just move the printer around, but like this one right here, okay, this one's gonna fall on me. It's just gonna continue to do this. So if I just put a tool in just to hold it while we're trying to settle things up, that will enable us to be able to do what we need to do without chasing it the whole time. So we're gonna need an M5 screw in there, and we're using M5x10s again. So I'm gonna try to do this kind of single-handedly. There we go. And let's see, M5x10, yeah, M5x10. All right, so we get that one there. And let's get the second one in. Another much deliberated thing about printing when you get to this point, when you're meshing plastic parts with metal parts, is whether or not to use thread locker. So I got two things I'll say about that. One is, I think it's blown out of proportion as to how bad thread locker is from most plastics that we use with 3D printers. It's absolutely horrible with polycarbonate. It's not so bad with ABS or ASA. So, you know, grain of salt on some of those things. However, it does have an effect on plastic. Now, the benefit is that obviously it locks nuts in, but when we're actually going through plastic into metal, through metal, we actually get the effect of the fact that the plastic almost works a little bit like a sponge or a little bit of a spring. So it's almost like a lock washer on some of these things. So I don't feel that if you're doing normal maintenance on your printer, when you have plastic parts connected to a metal part, that you need to basically fuss much about putting thread locker on it, especially if you're concerned about the effects of thread locker on your plastic. So that is said. All right, so we got to get these ones all lined up as well. I'm gonna flip this around again, and do not hesitate to flip things around. You know, I wouldn't beat your printer around too much, but it's plenty rugged to be able to flip it around and do things like that. So don't overly concern yourself when it comes to getting a good angle on things. And once again, This piece is kind of a support piece, but I do know in the manual they want us to look to make sure we get 90 degrees on this. And that's more or less to make sure there's no racking happening between this section right here so that our gantry is relatively flat. So those are loosely in, and right here is where they want us to measure the 175 and the 90 degrees. So 175 is from inside to inside. I'm going to do that real quick. And that is for 250, add 25 for 300. So 200 on the money is what we're looking for. And 200 is what I have there. And I should also have it here, unless there's something really weird happening with the physical world. I do. And if I measure that again up top, it'll also give me a pretty good idea as to how square it is. And I will tell you that, let's see, it's pretty close. So, and then 90 degrees. How to test for 90 degrees? Good question. I have one of these guys, and I don't know if you've seen these before. These little, this one's from Chaotic Labs. I bought this one, but these are pretty good. These help you basically figure out if your frame is square. So basically, if this fits over your frame pieces, it's seen as being square. And that one's actually a little tight. I might have pulled something a little bit out while I've been working today. So I'm gonna have to look at that here in a few moments, probably off camera, but that works well for that. It will not work for this. So what can I do to check my 90 degrees? I'm going to grab a real square. I'm gonna have to hold it at a slight angle, because it is actually, we can do this. You can hold it like this, yep. And what I'm looking for here is to hold it nice and tight to one side, and then A, does it fit in? And B, can I see light through it? So I'm not seeing light coming through. I'm gonna do both sides. If you do one, they both should be fine, but if for some reason your tool happens to be ever so slightly off and your frame just happens to be off in the exact same direction, you won't notice it. So, and then over here, I'm also going to say it is pretty much dead on as well. So that's good. I gotta remember to look at this corner though, which I'm not gonna do right now because that's on me. All right, right here, adjusting positioning, we have our 175, we have our 90 degrees, and then we have all that. They want us to put our second piece in. We have them both in, they're still loose. So I'm gonna go ahead and tighten those up a little bit. Now that we are where we need to be. And I have to do that. Do that. There we go. Good. Yeah, upside down assembly. What a novel idea. Cool. All right. Linear rails. Not gonna get linear rails on today, it'll be the next video, but what I do want to tell you, or what I want to leave you off with so you come back and watch the next video, is my kit for cleaning linear rails, because unless it is specifically notated that your linear rails have been 100% cleaned and lubricated, and I don't mean packing grease, you need to clean your rails. So what are you gonna need? Gloves. Strongly suggested. Something of a vessel to collect air to blow things out of, a little bit of light oil of some sort, some EP2 grease, and I like some isopropyl alcohol in a spray bottle. That all being said, I'm going to clean one rail real quick for you. And I'm going to do the rest off camera between now and the next video, and we'll get these rails on for the next video. Now, if you look at a rail, they tend to come with stoppers on them, which is good. Leave those in. Don't mess with them. Don't take those out until you have to. Last moment is good with that. So I will basically, first thing I like to do is just basically clean off everything. I'm going to give this a little bit of a bath of isopropyl alcohol right off the gate. Grab myself some paper towels. This is more for show than anything else because I want to see what dirt we will see. So what do we got here? Yeah, we got some dark spots. Yeah, cool. All right, now we did that. Forgot to put my gloves on. Let's put the glove on. Let's get that done. There we go. All right, so first thing I want to do is basically flip this bad boy over like so. Put it inside your container, whatever you got. And the way I like to clean them, because I don't like taking these things apart. I do if I have to, but honestly, it scares me because the ball bearings are tricky little fussy little gremlins that will go anywheres and everywheres without even a second thought. So what I like to do is on the back of your linear rail, you're gonna have a bunch of holes. Just put some holes behind your carriage like so. And I actually line this up and I just basically pump in some isopropyl alcohol. And I just basically pressure wash it from the inside. I know it's working because I see it coming out the other hole. And that will help me just make sure I get everything out of there. And every once in a while, I'm gonna basically do this with it, and that's basically moving those little ball bearings around, just to get them moving around, get that isopropyl alcohol all over everything. So now that I've safely cleaned off my rail, I've pressure washed the carriage, I can now kind of dry it off here pretty quick to an extent. And it is substantially louder, which is good because the oils that were in there, the packing greases, whatever, are gone. Now let's talk about linear rails for a second. This linear rail has a pretty decent preload on it. And what a preload is basically how tight your ball bearings are to the actual rail. Now you might look at this and say, that is a horrible rail because it's not moving on its own. You should be able to bring it up and drop it right down because it works really smoothly. The problem with that is if you have rails that basically you push up and on their own weight they come down, that rail will have more play in it. And when I say play, I mean wobble. We don't want wobble. Our stepper motors are perfectly capable of moving around a linear rail that has a little bit of drag, and we want a little bit of drag on that because we want pressure between our ball bearings and our actual steel rail here. Without that, if there's no pressure, if there's even the smallest micro gap between those ball bearings and this steel that's on here, that's room where things can move around. We do not want that whatsoever. So I'm going to call that one good. And like I said, it's got a decent preload on there. This is from KB3D. I'm wearing his shirt today. It's Chris. Yeah, we're going to call that good. So next step I do when I'm working these things is check to see if there's air in my can. And then I basically give it a good little blow. I just want to blow things out. And then I go right back into the same holes I used with the isopropyl alcohol. And I blow those out too. I want to make sure that I get as much drying as possible. Now, the good thing about isopropyl alcohol, especially if you're using something that's 99% or 97%, is it will dry by itself pretty quickly. Matter of fact, this one right here is already pretty much dry. If I was doing this in mass, if I was going to do all my rails right now and not as a kind of a show and tell here for this, what I would do now is basically leave this where it is, set it aside on a piece of paper towel, let it hang out for a while. Maybe, by the time I get done with the last rail, which might be another 15-20 minutes, be 100% ready to go. And then I would move forward with that. But today, because we're doing what we're doing, I'm just going to move forward here a little bit. So I'm going to open this up. This is a preloaded syringe, also from KB3D. Chris kind of knows that when you buy a Mobilux EP2, there's really only two ways to get it. One is preloaded in syringes like this at a relatively high cost, admittedly, or you buy a big gawking tube of it that you really don't need. So, I do have a big tube, but why not, right? So I now put my end in it. It came inside the tube, only one. I'm surprised there's only one in there. So I'm gonna give this a little bit of a squeeze. So I just start to see the oil come, or the grease coming out of this. There we go. Clean that off. And now we're basically going to load our carriage with grease. So there is a hole on these things right here in the top, and you're going to have to apply some pressure downwards as you basically squeeze the grease into the bearing, and you're not going to feel things move much because we're talking minimal amounts. But I do see grease here, which means it's getting in there and it's getting into the railways for those bearings. So I'm going to flip this over. I'm going to do the same thing. I'm going to put pressure on top of my grease needle here, my little outlet for grease. Give it a good little squeeze. And again, I see it there. I can feel it too. The crunchiness I had a few moments ago is gone. The preload is still there. That will not go away. But basically I can feel that there's lubrication now in there with those bearings. I'm just going to give it another little shot there. Yep. So there's actually quite a bit of drag there. And that's really what you want. You want drag on these carriages. And you'll get a feel for it. It definitely should have more drag on it than when you open it. You might find the grease stinks a little bit. Forewarning. So once you get to that point, it should be pretty good. Another place where you can apply some grease if you choose to is here in these back holes. You can put a little bit in there. It's a little bit out on whether or not that does much really, but basically now we have a greased linear rail. The last thing I like to do is take a not alcohol soaked paper towel and just give it a quick wipe. And I like to put a little bit of oil. Back in the day, it was really popular to use sewing machine oil. But I just use a little bit of 3-in-1 oil, and I'm just going to put it on the steel surfaces here, and it's water thin. It's just basically to keep everything lubricated and protected while we finish our build. There you go. One rail ready to go.
All right,
that's the video for today. We did those AB drives, we did the Rama beefy front idler mods that we did ourselves in-house. We went ahead and cleaned up that linear rail, so that will be on the next video. So if you haven't yet checked out the channel and checked out my other videos, please do so. There's a huge backlog of video on 3D printer builds. If you haven't given me a thumbs up and you did enjoy the video, I do appreciate every single one I get. Comments are always welcome, and I'll see you next video.